Now that the university's data sits neatly in tables, a new problem appears. Two students share the same name. A teacher is linked to the wrong class. Searching for the right record becomes unreliable. Without a way to distinguish each entry, even the best designed tables start to break down. So the question is, how do we make sure every record in a database is distinct, trustworthy, and easy to connect with the rest? Before we dive into the different types of keys, let's step back and ask, what exactly is a key in a database? A key works like a digital tag that gives every record its own identity. It makes each row unique, prevents mix-ups when data looks alike, and creates the links that connect information across tables. Just like a student's roll number separates one person from another, keys keep databases organized and dependable. In a database, keys act like special identifiers and links that help keep data organized, unique, and connected. Different types of keys serve specific roles. Some make sure each record is unique, while others create relationships between tables or enforce certain rules. Understanding these types of keys is essential for designing and maintaining a reliable database system. Let's explore the main types of keys you'll encounter. A primary key uniquely identifies each record in a table. Think of it as a student's roll number. No two students can share the same number, and it cannot contain null values. Here's an example where student ID is the primary key. Sometimes more than one key can uniquely identify a record. These are called candidate keys, but only one of them becomes the primary key. For example, in this table, both application ID and passport number are candidate keys, as they uniquely identify each applicant. In a table, when a single column cannot uniquely identify a record, we combine two or more columns into a composite key. For example, in this enrollment table, student ID and course ID together form a composite key to uniquely identify each enrollment. A foreign key connects one table to another by pointing to the primary key in the related table. For example, in the courses table, teacher ID is a foreign key pointing to the teacher ID in the teachers table, linking each course to its teacher. Keys make every record unique and easy to find. Keys link data across different tables. Keys keep data accurate by preventing duplicates and broken links. Keys improve efficiency by speeding up searches and organizing information. Without keys, databases would be messy and slow. With keys, data stays clean, connected, and reliable. Keys are what turn raw tables into trustworthy systems. They don't just prevent duplicates or link records. They're the reason we can search, connect, and rely on data at scale. Every time you register for a class, pay with an app, or look up a record instantly, keys are working quietly in the background to keep the digital world organized and dependable.